Hello there. Welcome to the Sleepless Scientist, where your imagination can roam even while you rest. Tonight, you're not just lying in bed, you're standing at the edge of the world, watching the sea breathe in moonlight. Have you ever truly noticed it, the tide curling over the sand like fingers on a lullaby piano, and then slipping back, quiet and endless? If you're still awake, tell me, what time is it where you are? What do your skies look like? I wonder if the moon is watching you too. Tonight, we'll sink into the mystery of tides, that strange, silent motion that stirs our seas and sculpts our coasts, all because of an ancient cosmic dance. But fair warning, if you're hoping to escape gravity, you probably won't survive this, because we're going with it, pulled, stretched, and lulled by invisible forces as old as time itself. And if you enjoy drifting through science like this, don't forget to tap that like button. Maybe even subscribe so we can wander again. Now hush and listen. You lie still now in the dark hush between your breath and the night. But in that hush, far away, the sea is never still. Even on windless nights, when the surface is flat as sleep and black as ink, it moves, slowly, massively. You can't hear it from here, but down in the abyss, water stirs, rises, retreats. It's like the whole ocean is breathing, not in seconds, but in hours, in long, deep planetary sighs. The tide is not a wave, not a splash, not even a storm. It's a pulse, a whisper beneath the waves, a slow-motion rhythm that you only notice when it's already changed everything. It isn't random, it's not chaos. If you had the patience of a barnacle or the memory of a cliff, you'd notice the water always comes back. It arrives early some days, late on others, but it always comes and it always goes. This rhythm was here before pyramids, before fire, before even bone. And always it has whispered to those who lived near the sea, "Watch me, I will show you the clock of the cosmos." Some say the ocean holds memories, and maybe it does, but the tide is memory, a moving journal tugged at by the moon, shaped by continents, and written on every beach in salt and foam. It's easy to forget the power of something so slow, but tonight we remember. You're standing on a quiet beach now, in your mind at least. The stars are clear, the air smells like salt and night. Somewhere out there, past the dark horizon, the moon is rising. You don't see it yet, but already the sea knows. Already it begins to stir. Long ago, people believed the tide was a creature, a giant sea serpent, perhaps, rolling just beneath the surface. Others thought it was the breath of the sea gods, Poseidon in Greece, Manannán mac Lir in Ireland. Their moods, their movements, these caused the waters to rise or fall. And maybe they weren't wrong, because even now, with all our satellites and sensors, we can't explain everything. Scientists still argue whether small tidal irregularities in enclosed bays are caused purely by local geography, or if something deeper, something planetary, nudges them. One mainstream truth is certain, though: the tide comes from gravity, and most of it, not all but most, is the moon's fault. You see, the moon pulls at us, always has, not just on lovers and lunatics, but on water. The moon's gravity reaches across the 384,000 kilometers of space between us and tugs gently, very gently, at Earth's oceans. It lifts them, just a little, maybe half a meter out in the open ocean, but that's enough. What's wild is that you've probably never noticed this at sea, because unlike storm waves that come and crash in minutes, tides rise over hours. They're lazy, regal, measured. A quirky fact: the first person to formally connect tides to the moon's Scythian was Seleucus of Seleucia, a Babylonian philosopher from the 2nd century BCE. He noticed that when the moon was overhead or opposite, tides peaked. He had no modern physics, just observation and wonder, and he was mostly right. But there's more to it than just moon pulls water, water rises. It's also about inertia, the resistance to movement. The Earth and moon are actually in a constant tango. As the moon pulls Earth, Earth pulls back, and this interaction stretches our planet just a bit, not just in water, but in rock too. The land rises by centimeters. The ocean? Much more. That's the tide you feel lapping at your toes. Not just a motion, a message from space, a celestial finger tracing patterns across the blue skin of our world. But you don't need to know physics to feel it. Fishermen know, sailors, children building castles too close to the shore. The tide comes and it goes, always. At Mont Saint-Michel in France, you can stand on dry land one moment and find yourself completely surrounded by water the next. Tourists have been stranded, even swept away, because the tide isn't just slow and gentle. Sometimes it rushes in, fast enough to gallop alongside, and always it obeys a schedule older than any clock. And it's not just humans who've noticed. Some corals spawn only during certain tides, as if reading the moon's diary. Horseshoe crabs swarm beaches to lay eggs on full moons. Even ancient stone monuments, like the mysterious Pictish tide markers in Scotland, were built to predict and honour this celestial breath. The tide is old, and it is wise. It teaches us patience, teaches us to listen. So tonight, you lie back and listen. Imagine the water out there, not crashing, not howling, just pulsing, gently rising, gently falling, as it always has, as it always will. The tide is already moving now. You feel it more than see it, the distant, slow inhale of the sea, as though something vast and gentle is lifting the water almost imperceptibly from beneath. It doesn't roar, it doesn't splash, it retches. And the force behind it? The moon. Not some mythic goddess or jealous sea god hurling tridents, but a grey, silent orb of dust and stone hanging in space. Still, from nearly 400,000 kilometers away, she tugs on our planet with invisible strings, a soft, constant pull, and your world responds. You see, Earth is not solid through and through. Its oceans, and even its crust, are more pliable than you might expect. Think of the moon's gravitational pull as fingers pressed gently against the surface of a vast water balloon. The water bulges toward it. That's your first high tide. But here's the curious thing. The moon doesn't just pull on water, it pulls on the entire Earth. And the water on the far side, the part facing away from the moon, bulges out too. Wait, how can that be? If gravity is pulling one way, why would the water on the other side also rise? It's a strange ballet of forces, and inertia is the quiet partner. As the moon pulls Earth toward itself, the ocean on the far side resists, due to inertia, the tendency of an object to remain in motion or at rest. That resistance causes a second bulge trailing behind. One high tide faces the moon, the other high tide, almost poetically, faces away, and the Earth spins between them, rolling under these watery humps like a lazy skater twirling beneath two massive spotlight beams. That's why, as the night passes, you often get two high tides, one roughly every 12 hours and 25 minutes. Not exactly 12. The moon takes just over 24 hours to appear in the same spot in the sky again, and the tides follow her, not our clocks. It's why tides shift each day, why the sea might come lapping at your toes just after breakfast on Monday, but not until lunchtime by Friday. And it all begins with gravity, that quiet, relentless force. Sir Isaac Newton, yes, the apple guy, was the first to formally explain this. In 1687, he published his theory of universal gravitation, and in doing so, he cracked the secret of the tides. He showed that not just the moon, but any two bodies with mass attract each other. Even you, lying there in your bed, are being pulled by the moon. It's just that your mass and your friction with the mattress keeps you grounded. The ocean has no such grip. But Newton wasn't the first to wonder. The ancient Greeks noticed the correlation, the Romans had tide charts, and the Polynesians, master navigators of the Pacific, timed their voyages by the moon's cycle. Yet it wasn't until Newton that science had an answer grounded in math. Still, even his explanation wasn't perfect. Because even now, scientists still argue whether Newton's model fully accounts for all the tiny tidal anomalies we see, especially in places with narrow bays or dramatic coastlines. Is there some amplification due to seabed geometry, or perhaps subtle resonances we haven't yet mapped? Some say yes, others aren't sure. What we do know is that the moon's pull doesn't act alone. But before we get to that, pause for a moment. Think about what this means. The moon, drifting through the cold void of space, can move oceans. That tiny crescent you barely glance at, it reshapes the boundaries of continents, carves coastlines, and drives ecosystems. It's the most romantic form of control, effortless, silent, constant. No wonder poets have always been drawn to her. The moon isn't just a satellite, she's a sculptor, and her art is movement. Now, let's think for a moment about the shape of those tides, because they don't just rise vertically, like water in a bathtub. They rotate around points in the ocean called amphidromic points, where there is little to no tidal rise. Around these invisible centers, the tides satas whirl in vast, slow-motion whirlpools. Stand at the edge of one of these points, and you'll feel the water pulse beside you, up and down, with a rhythm like a heart. But move just a few hundred kilometers and the tide might rise by 5, 6, even 10 meters. This unevenness is one of the quirks of tidal science. Not all coasts experience the same tide. The Bay of Fundy in Canada famously has the highest tidal range on Earth, over 16 meters on a good day. Meanwhile, in the Mediterranean Sea, the tide barely moves. Why? Because the ocean isn't a flat bowl. It's a jagged, irregular basin, and the moon pulls not on a perfect globe, but on a mess of trenches, ridges, and continental shelves. That's why you can't predict tides just by looking at the moon. You have to know the coast. Local geography matters. In fact, in the Netherlands, the ancient Frisians used wooden stakes hammered into the mudflats to track tidal shifts across seasons. The Celts used shadow stones aligned with lunar cycles, and in Japan, fishermen placed coloured ropes on their boats, red for spring tide, blue for neap. When the water reached the colour, it was time to launch or return. A charming tidbit. In medieval England, there was a tide bell in coastal churches, rung not for prayer but to alert townspeople that the harbour would soon flood. Imagine the sound. A single clang echoing over moors and marshes, telling you the moon had shifted and the sea was on its way, and it always came. Even now, in your mind's eye, the tide has crept a little closer to your feet. The sand is damp now. Foamy fingers curl forward, then retreat. The moon is higher, casting a pale silver across the dark water. You don't feel her pull, but you can see it, in the hush of the waves, in the subtle rise of sea against shore. The ocean is not crashing tonight, it's whispering, to you, to the moon, to the stars, beyond. And so, you lie still, breathing with the tide. Out on the beach, the water is rising still, slow, deliberate, patient. It doesn't surge like a storm or spill like a broken dam. It lifts almost politely, creeping up the sand grain by grain. There's no chaos here, just rhythm, just the ancient whisper between Earth and its ever-watchful moon. But tonight you begin to notice something strange. The moon hasn't moved, not really, yet the tide is changing again. It's pulling in opposite directions. How can water be rising both beneath the moon and away from it? You already know the moon's gravity lifts the ocean closest to it, forming what we call the direct bulge. But now, as you tilt your mind toward the other side of Earth, the one turned away from the moon, you realize there's a second high tide forming there too. That one isn't pulled, it's flung. Here's how it works. The Earth and Moon are bound together, not just emotionally but physically, orbiting a common centre of mass, a point known as the barycenter. This point lies about 1,700 kilometers beneath Earth's surface, slightly off-center. Because of this shared orbital dance, Earth is constantly in motion around this invisible fulcrum, and that motion creates a kind of outward fling, a centrifugal force, like the feeling in your stomach on a merry-go-round. That outward force pushes water away from the center, not by gravity, but by motion. It causes a second tidal bulge to form on the side opposite the moon. So the tides don't just rise because of what pulls, they also rise because of what spins. The result? Two high tides on opposite sides of the planet, tracking with the moon as Earth spins beneath them. One caused by gravity's embrace, the other by inertia's subtle protest. It's a celestial tug-of-war, but nobody's losing. You might picture the Earth covered in a stretchy blanket of water, pulled slightly into an oval shape, longer in the moon's direction and away from it, thinner around, to the equator. As Earth rotates, different parts pass through these bulges, and that's what causes the rising and falling water levels you see at shore. Now imagine standing on a dock at sunrise, waiting for your boat. You hear the creak of wood against wood, ropes tightening and the occasional splash of water beneath. The tide has risen while you slept, gently lifting the hull higher and higher against the moorings. You step onto the deck, barely a difference from the pier now. You don't think about the moon. But she's there, always there. And still, even with Newton's and modern physics, not every detail is fully understood. Scientists still debate how deep ocean inertia interacts with seafloor friction, or how turbulence and temperature might slightly shift tidal behavior. In deep, open waters, the bulges can circle smoothly, but near shorelines, the complexities grow. In fjords and bays, tides sometimes appear to arrive hours late. In places like the Gulf of Mexico, the expected pattern of 2 highs and 2 lows per day becomes lopsided, a single distorted rise and fall instead. Local topography plays its part, but not every twist has been mapped. Even now, computer models struggle to predict tides with perfect accuracy in some coastal corners. And in certain narrow channels, high tides can occur almost in reverse, seeming to pulse inland before they rise at the mouth of the bay. A quirky tidbit: in parts of the Indian Ocean, local myths claim that sea spirits or ancestral ghosts block the tide once a month, delaying its arrival. These beliefs aren't superstition, they're observations passed through generations. It turns out those ghosts may align with complex resonance patterns caused by overlapping lunar and solar cycles. And yes, solar cycles matter too, but we'll drift there in a moment. For now, stay with this image. The Earth spinning beneath 2 tidal bulges like a dancer turning under twin lanterns, her watery dress trailing in slow-motion arcs across the globe. There's beauty in that. Precision, yes, but also something soothingly imperfect. The tide is never exact. It's close, predictable, yet fluid, like a lullaby sung slightly differently each night. If you lived on the open sea, on a ship without anchor, you might not even notice it. The ocean lifts your vessel so gently that it feels like part of your own breath. But near the coasts, the difference is dramatic. Tide pools are born from these motions, delicate little ecosystems that appear and vanish with the moon's pace. The sea withdraws, revealing worlds of anemones, tiny fish, barnacles, and sea stars. They glisten like jewels under starlight, stranded momentarily in the air. Children gather around them, pointing with sandy fingers, marveling. By morning the water will return and wash it all away, not in violence, but in ritual. Somewhere in Cornwall there's an old fisherman's saying, "The sea never forgets its steps, only the dancers change." And in that rhythm we find peace. Even ancient cities learned to move with the tide. Venice, for example, built its palaces with doors that accommodate tidal shifts, the lower levels often flooded during high tide. In places like the Maldives, locals place markers on trees and posts to predict flood levels, not just annually, but lunar cycle specific. And then there are the miscalculations, eerie and poetic. In 1962, the Dutch tried to test nuclear devices beneath the sea, but the tide interfered with the timing of water displacement in their calculations. The test yielded not just data, but flooded labs and puzzled engineers. Even science can forget that the moon watches everything. The 2 tides, gravitational and inertial, continue their planetary waltz, reshaping the shorelines bit by bit. Some beaches grow, some shrink, sandbars drift like sleeping whales, and rocks worn down over millennia become smooth stories beneath your feet. Imagine how many tides have passed since the first breath on Earth. Since the first fish crept from salt water to sand, since the first sailor looked up at the moon and thought, "She's following us." And maybe she is. Perhaps she follows you too, not in malice, but in memory. Every tide you've ever stood beside is her reply. And tonight, as the water curls slightly higher onto your imagined beach, you lie still, listening. The tide is changing again. You lie there, eyes closed, but your mind is still gently adrift. out where the sea breathes slow, deliberate breaths, and the moon's invisible fingers pull the world's oceans into motion. Yet tonight, you don't just follow the water's rise and fall. You begin to sense a larger motion beneath it all, because Earth is turning. As you float through this slow dream, it becomes clear. Tides are not only a result of the moon's pull or of opposing bulges or distant barycenters, they are choreographed by time itself. The Earth spins not once in a lifetime, but every 24 hours, dragging continents, skies, and oceans beneath the steady gaze of the moon. And it is this turning, this daily pirouette, that transforms celestial tension into movement you can feel underfoot. Earth's rotation beneath those two bulges, remember them? One facing the moon, one facing away, is what causes the tides to arrive and retreat across your coastline. As Earth spins eastward, a location on the surface moves into the bulge, high tide, passes through it, then exits into the area between bulges, low tide, and finally enters the second bulge, another high tide. Then the cycle repeats. But here's where it gets delightfully complicated. Earth doesn't rotate in perfect sync with the moon. The moon orbits the Earth every 27.3 days, but it also moves forward a little bit each day. Because of this, the tidal cycle is not ever 12 hours exactly. It's about 12 hours and 25 minutes. This means that every day, the tides arrive roughly 50 minutes later than the day before. That's why when you walk the same beach at the same time each day, the water may be kissing your toes on Monday, but be far out beyond the sandbars by Friday. You are watching a slow-motion race between Earth's rotation and the moon's orbit, and it never ends. This slight lag creates what's called a tidal lag, the delay between the moon being directly overhead and the actual time of high tide. In most places, the water reaches its peak about 1 to 2 hours after the moon crosses overhead. It's as though the ocean is always trying to catch up. This lag isn't because the moon is being lazy, it's because Earth, ever the restless spinner, is moving faster than the tide can respond. Like a pot of soup being swirled in circles, the momentum, the drag of continents, the shape of ocean basins, all conspire to slow the water's response. This dynamic interaction gives birth to what's called the dynamic theory of tides, which accounts for the influence of Earth's rotation, the shape of ocean basins, and the Coriolis effect. Ah yes, the Coriolis effect, a subtle twist in the dance. Because Earth is spinning, anything moving over its surface appears to curve, to the right in the northern hemisphere and to the left in the southern. This is why hurricanes spiral, why weather patterns rotate, and why the tides, which are after all enormous masses of moving water, bend slightly as they sweep through the oceans. It's not just gravity and motion, it's choreography. It's an ancient performance played out in billions of tons of salt water shifting across the blue face of a spinning planet. And that choreography is complex. In some places, like parts of the eastern coast of North America, you experience semi-diurnal tides, 2 roughly equal high tides and 2 low tides each day. But in other regions, such as the Gulf of Mexico, tides behave diurnally, with just 1 high and a 1 low tide every 24 hours. And some places, like certain parts of Australia or Southeast Asia, experience mixed tides, unequal highs and lows that don't seem to follow any perfect rhythm. Why such variation? Blame the Earth itself. Our planet is not a perfect sphere. It's slightly flattened at the poles, bulging at the equator, and our oceans are not uniform basins. They're littered with seamounts, ridges, trenches, and irregular continental shelves. These physical features interfere with the clean bulge and spin model. Even islands can throw a wrench in the tide's flow. In the Pacific, there are tiny specks of land, volcanic dots that redirect entire tidal waves, fracturing them into eddies and whirls. These localized disruptions cause variations that are still being mapped even by today's oceanographers. In fact, scientists still argue whether these irregularities are best modeled by existing mathematical simulations or whether we need more real-time satellite data to understand the minutiae of local tidal behavior. A lovely fringe fact: There are places on Earth where the tide arrives sideways. In parts of the British Isles, like the River Severn in Wales, a phenomenon called a tidal bore occurs. It's a literal wave, sometimes up to 2 meters high, that travels upstream against the current of the river. It's caused when the incoming tide is funneled into a narrowing estuary, speeding it up into a wall of water. And it doesn't sneak in silently. It announces itself with a low, rising hum like a distant engine. Locals have even given it a name, the Great Severn Bore. Some daring souls surf it, catching a ride not from a storm or a sea swell, but from the moon's quiet pull funneled through Earth's shape. You might think that's an isolated case, but tidal bores exist in over 60 rivers across the globe. The Amazon has one called the Pororoca, a thunder muddy wave that rushes inland for kilometers, flattening forests and flipping small boats. It's not an everyday tide, it's the tide in dramatic costume. But whether gentle or wild, predictable or peculiar, all these tides trace their lineage back to the same celestial rhythm, Earth turning beneath twin bulges of water, always a little behind, always catching up. So tonight, as you float in this whisper of planetary motion, consider your own place in the spin. You're lying in a bed, still and silent, and yet beneath you, your body is being flung through space at nearly 1,600 kilometers per hour due to Earth's rotation. Around you, the oceans respond to forces invisible, ancient, constant. The tide is more than just water moving, it is time made visible. And as you lie here, the tide somewhere continues to rise or fall, as it always does, as it always has. The moon watches, the earth spins, and you, small and still as you are part of it. The dancer, the wave, the pause between. The water is high now, you can feel it, even if you're not standing on the shore. There's a fullness in the air, a kind of silent pressure that hovers at the edges of your imagination. The moon has pulled the ocean close, and it has obeyed. But just as you begin to settle into this rhythmic rise and fall, something changes. The sun arrives, not in a blaze of light or heat, not yet, but you sense its presence, distant and vast, slipping into the tidal conversation. The moon's gravitational tug is no longer working alone. Now, the second great force in this cosmic ballet takes the stage. You may have thought the sun too far, too distracted, or too fixed in its orbit to matter much to the tides. After all, it sits 93 million miles away, over 390 times farther than the moon. But gravity, ever the patient influence, doesn't rely on proximity alone. It also depends on mass. And the sun is massive. In fact, it's 27 million times more massive than the moon. Its gravitational pull on Earth is enormous, more than enough to hold our planet in orbit, to fuel the seasons, to define day and night, and yes, to shape the tides. Despite the moon being the dominant sculptor of tidal bulges, the sun contributes nearly half of the tidal force. But unlike the moon, the sun's pull is steadier, broader, a slow, commanding conductor rather than a nimble dancer. Its influence adds a second layer to the rhythm you've come to recognize. Here's where things get beautifully intricate. Sometimes the sun and moon work together. They line up, either on the same side of Earth during a new moon or on opposite sides during a full moon. When this happens, their gravitational pulls combine, and the result is something called a spring tide. It's a slightly misleading term, not related to the season of blooming flowers, but instead from the Old English springan, meaning to leap, and leap it does. During a spring tide, the high tides are higher and the low tides lower. The ocean stretches a little further, the tidal range expands, and coastlines around the world experience the full reach of gravitational unity. Imagine it. Both the sun and moon pulling in the same direction or in perfect opposition, one tugging forward, the other back, stretching the sea like a piece of silk across the globe. The waves roll a bit farther up the shore, harbours flood more dramatically, mudflats widen, gleaming under moonlight. But just as often, the sun and moon find themselves at cross purposes. During the first and third quarters of the lunar cycle, the moon and sun are at right angles to each other in relation to Earth. Their gravitational forces partially cancel out. The moon tries to pull the ocean north-south. The sun tugs east-west. The result? Neap tides. These are gentler tides. The highs are not so high, the lows not so low. The difference between them, the tidal range, becomes smaller. The sea seems to hesitate, uncertain it is. Inches forward, then pulls back with restraint. In some regions, neap tides are barely noticeable. In others, they provide brief reprieves from the more aggressive spring tides. Fishermen, harbour masters, and even nesting seabirds pay close attention. A mistimed launch during a neap tide can leave a boat stranded in muck. A bird's nest placed too low could be drowned in the next spring surge. Even now, certain cultures chart their lives by this rhythm. In Japan, the Shinto calendar still accounts for Rokuyo, 6-day cycles that include lucky and unlucky tidal alignments. Fishermen in parts of Southeast Asia avoid launching on neap tides, believing the spirits rest then. And in Scotland's remote isles, there's an old belief that the sea listens best when the sun and moon agree. You lie still, listening to that agreement, and the occasional disagreement. A fringe curiosity? During the full moon, when the Earth lies directly between the sun and moon, the tides are stronger. But so are the psychological effects, or so folklore claims. Emergency rooms see a slight uptick in visits. Police report odd behaviours. And though science hasn't proven a strong link, the stories remain. The word lunatic isn't just poetic. It comes from luna, Latin for moon. Perhaps our blood, like the sea, feels the pull. After all, you are mostly water. You're a small ocean walking upright, listening to the same gravity that moves continents. And what of eclipses? When the sun, moon, and earth line up perfectly, and we experience a solar eclipse, new moon, or a lunar eclipse, full moon, tides often surge with even greater intensity. These moments bring unusually high spring tides, sometimes called king tides, which flood low-lying coastlines and swallow entire stretches of beach. In cities like Miami and Bangkok, king tides now cause sunny day flooding, where streets fill with seawater not because of storms, but simply because the Moon and sun have aligned, and the sea obeys. Scientists still explore how rising sea levels interact with these extreme tides, whether urban drainage systems can adapt, or if coastal architecture must evolve to a rhythm older than bricks and blueprints. The moon and sun, patient and indifferent, care little for human schedules. Their song continues. A historical note. Galileo once believed the tides were caused by the Earth's motion, sloshing water in response to planetary speed. He was wrong, of course. Newton corrected him. But Galileo's intuition wasn't entirely useless. He understood that the sea was in constant motion, and that celestial mechanics shaped that motion even if he couldn't fully explain how. That's often how science works. One wrong idea gently nudged by better ones until the truth begins to form, like a tide rising over submerged rocks. You may find it soothing to realize this. Even when we didn't understand the tides, they still came. Even when humanity had no word for gravity or orbit or tidal range, the sea knew, the moon knew, and together they kept time without asking our permission. Tonight you are part of that timing. Your breath rises and falls slower now. Somewhere out there, another coastline lies bathed in moonlight. The sea presses forward just a little more, then begins to recede. A pier creaks, a heron lifts its wings. The stars remain fixed, but the ocean is moving. The moon pulls, the sun stretches, and you, curled beneath blankets, are wrapped in the softest of clocks, one made not of gears or bells, but of gravity and water. The tides, for all their precision, remain humble. They do not shout their presence, they do not demand your attention, but every grain of sand they move is a reminder. The universe is in motion, and you are not separate from it. You are part of the tide, and the tide is not over yet. The tide, now high, has begun to fall. The tide, now high, has begun to fall. But not in haste. The retreat is as graceful as the rise, slow, unbothered, inevitable. The waves pull back inch by inch, drawing long strands of kelp across the sand, leaving tiny bubbling pools in their wake. You watch it unfold, not with urgency, but with awe. The ocean is exhaling again. Yet something tugs at your attention. deeper than the water itself, because this dance of the tides, so cosmic in its cause, is not playing out on a smooth, uniform stage. No, beneath the water's silver skin lies something far more complex, something rough, craggy, sculpted over eons by heat, pressure, and time, the seafloor. You've heard of tides in theory, moon, sun, inertia, and Earth's spin, but now we must follow the tide downward into the depths, because the way the water moves, how high it rises, how fast it rushes in or out, all of that depends on what lies beneath. You see, the ocean is not a flat bowl. It is a planetary landscape of mountains and canyons, volcanoes and trenches, slopes and shelves. These features, collectively known as bathymetry, shape the behavior of tides in subtle and startling ways. Take the continental shelf. It begins at the edge of every continent, a broad, shallow slope that extends beneath the sea for tens or hundreds of kilometers before dropping sharply into the abyss. The shelf acts like a tidal amplifier. As the ocean's bulges approach the coast, the shallow depth causes the water to pile up, like a traffic jam in a narrowing lane. That piling up transforms a modest offshore tidal bulge into a dramatic coastal high tide. And this isn't uniform. In places where the shelf is steep and sudden, like parts of the Pacific Rim, tides might rise and fall only a meter or so. But in regions with a wide, gentle shelf, like the Bay of Fundy in Canada, the tidal range becomes astonishing. There, the Osha, and can rise over 16 meters between low and high tide. That's more than a 5-story building, and it happens every 12.5 hours, like clockwork. Why so extreme? It's not just the wide shelf. The bay's shape, long and narrow, like a funnel, channels the incoming water, focusing the tide into a higher and higher wave as it rushes inland. It's like pouring water into a trumpet. The pressure builds, the water stacks, the tide booms, and sometimes it even rebounds. In Fundy, and in similar places like the Cook Inlet in Alaska or the Severn Estuary in the UK, the retreating tide can form a tidal bore, a wave that travels against the river's flow, surging upriver in a single continuous crest. We've touched on these before, but their connection to bathymetry is worth repeating. The exact timing and power of a tidal bore depends on the shape of the riverbed, the depth of the estuary, and the angle of the incoming tide. You can surf these waves, and people do. There's even a surfing event each year on the Severn, where brave souls try to ride the bore as far as they can, up to 20 kilometers inland. But back to the depths. Underwater ridges and mountain ranges, like the Mid-Atlantic Ridge, deflect tidal energy sideways, creating standing waves called amphidromic systems. These are bizarre features, points in the ocean where the tide barely changes and around which the tidal wave rotates. You could sit in a boat at one of these points and see hardly any vertical tide at all, even while nearby coastlines are drenched in meters of change. There are more than 25 of these systems across the world's oceans. The tides swirl around them in great circles, clockwise in the southern hemisphere, counterclockwise in the northern, another nod to the Coriolis effect. Now think of what that means. The tide you feel at your local beach might not simply be water rising and falling beneath. The moon. It might be the edge of a rotating wave system hundreds of kilometers across, shaped by underwater mountains, redirected by continental shelves, and sculpted by the planet's spin. And the effects ripple outward. In some places, like the Adriatic Sea, the seafloor is so shallow and flat that the entire basin acts like a tuning fork. The tidal energy resonates inside, creating local variations that can differ wildly from the open ocean outside. The water behaves like a bowl of jelly, quivering gently, out of sync with nearby coasts. Even seamounts, underwater volcanoes that rise from the abyss but never breach the surface, can split tidal currents, causing eddies and turbulence that affect ecosystems for hundreds of kilometers. Fish follow these patterns. Plankton blooms form and vanish with them, and deep-diving whales use them like invisible road maps. A lesser-known historical tidbit: during World War II, military planners miscalculated tidal currents around certain Pacific islands because they lacked accurate bathymetric data. The result? Amphibious landing craft got stuck on reefs, soldiers waded through unexpected mudflats, lives were lost, not to bullets, but to misunderstood tides. Even today, some remote seabeds are poorly mapped. The ocean is vast, and sonar scanning is time-consuming. Scientists still argue whether current tidal models, even with satellite assistance, are accurate enough to predict future changes as climate and sea levels shift. You pause for a moment, letting that settle. Beneath every tide is a landscape, unseen but inescapable. The moon and sun may direct the rhythm, but the sea floor sets the tone, the tempo, the subtle shifts in motion. It's like music written by two hands, gravity and geology, and together they compose a piece that has never truly stopped playing. Tonight, as the tide slowly falls from its peak, it doesn't merely retreat. It slides across slopes, flows down submarine valleys, and gathers speed in underwater canyons. Some of that water will be pulled into deeper currents traveling thousands of kilometers over years. Some will return in 12 hours. Some might remain trapped in coastal eddies, spinning for days. You, watching this from the warm cradle of your bed, are safe from these massive movements. But in your mind you can feel them. The gravity, the contours, the ancient pull of oceans following paths carved by fire and cooled by time. And even if you've never seen the seafloor, you've walked its story. Every shell, every stone on the beach, every shifting line of foam is a surface echo of the deep below. The tide falls quietly now. The moon, still watching, begins her descent. The stars seem clearer, the wind is softer, somewhere the low tide is preparing to arrive. In the silence between waves, you can almost hear the ocean settling back into the shape of its cradle. Not still, never still, just resting. Low tide now. The sea has exhaled. What was hidden is revealed. The water has drawn back like a curtain, and the stage beneath is littered with life. Rocks glisten with seaweed and mussels. Pools of salt water, warm and shallow, cradle tiny fish and transparent shrimp. Crabs scurry sideways between stones, wary of gulls. The air smells of brine, of sand and driftwood, of quiet cycles returning. This is the intertidal zone, a world that lives half in the sea and half in the sky, neither land nor ocean, yet claimed by both. For a few short hours, this strip of shore becomes a landscape of miracles. You might think of it as merely exposed sand and slippery stones, but it is one of the most biodiverse ecosystems on Earth. Creatures here are masters of survival. They endure extremes of temperature, salinity, desiccation, and predation, all in the span of a single day. You walk barefoot in your thoughts through this momentary world. To your left, barnacles line a rock like tiny armored bunkers. Each one is a little animal, sealed tight to preserve moisture, waiting for the tide's return. When the water comes, they'll open like flowers, feathery appendages waving in the current to catch plankton. To your right, a starfish clings to a submerged ledge, its slow-motion limbs creeping toward a mussel. Starfish have no brains, no blood, just a vascular system that pumps seawater through their bodies. And yet they hunt with purpose, prying open shells with patience honed over eons. A pool nearby reflects the sky. In it, anemones sway like underwater blossoms. Their stinging tentacles await the brush of a careless shrimp. In this calm, deadly garden, beauty and danger hold hands. The intertidal zone is not just a curiosity. It's a barometer of the planet's health. Every tidal cycle brings nutrients from the deep and carries waste back out to sea. Algae bloom, oxygenate the water, feed the grazers, who in turn feed the predators. When the tides falter, this cycle stutters. When pollution taints these pools, it affects creatures you'll never see. A strange, lesser-known tidbit? There are species of fish that live in these pools full-time, hopping from one to another when stranded. The Pacific leaping blenny, found on rocky shores in Samoa, actually crawls across land using its tail and pectoral fins. It breathes through its skin, a fish that walks, all because of the tides. This is how life bends itself to the rhythms of the moon. Some of the creatures here even time their reproduction with the tides. The grunion, a small silvery fish along the California coast, swims ashore during the highest spring tides to lay its eggs in sand. then it vanishes. 2 weeks later, just as the next high tide returns, the eggs hatch and wash into the ocean. No tide, no hatching. And in the mangrove swamps of Southeast Asia, the fiddler crab emerges from its burrow precisely when the tide retreats. Males wave their oversized claws in silent, synchronized courtship. It looks like 1,000 tiny soldiers saluting the moon. Even some coral reefs spawn based on lunar cycles, releasing tides, air eggs and sperm into the water during full moons when the tides are just right to carry their offspring far and wide. But why? Why do so many species tie their lives to the tide? Because tides offer predictability. In an unpredictable world, they are among the few rhythms that have never faltered. Every day for billions of years, the tide has come and gone. Long before clocks, calendars, or civilizations, life used this rhythm as its first measure of time. Even humans in our early days understood this. Our ancestors followed the retreating tides to gather shellfish. They watched the moon to predict where the water would be. The earliest known lunar calendars, carved into bones 25,000 years ago, seem to mark tidal and lunar phases. Before we tracked stars for navigation, we tracked the sea for survival. On the Orkney Islands off Scotland, Neolithic people built stone monuments aligned with tidal patterns. On Madagascar, ancient tribes constructed raised fish traps out of rock, walls that would be covered at high tide and strand fish as the tide fell. Ingenious, invisible at high tide, fruitful at low. There's a quiet genius in this kind of understanding, a wisdom not written in books, but walked with bare feet over wet sand. Yet even today, tides shape human lives. Entire economies revolve around them. Shipping routes are plotted based on tidal timing. Ports dredge their channels to match the lowest ebb. Energy companies now build tidal turbines, underwater mills placed in tidal channels to harvest the constant flow of water. These turbines generate electricity not with smoke or steam, but with the moon's pull. France's Reims tidal power station, built in the 1960s, was the first of its kind. It generates enough electricity to power 130,000 homes entirely from the daily rise and fall of the tide. Now, countries like South Korea, Canada, and the UK are RAC, being to develop more. Of course, not everyone agrees on the impacts. Scientists still argue whether large-scale tidal energy projects disrupt local marine life, or whether they can be designed to mimic natural flow. Can we borrow the moon's pull without unraveling the delicate systems that depend on it? It's an open question, but one thing is clear. The tide is power, both literal and metaphorical. And now, as the water reaches its lowest point, the world feels paused. The beach is wide. The pools are still, the horizon stretches, distant and faint in the moonlight. But the pause is not permanent. Already, beneath the surface, the sea is preparing to return. The moon has not moved far, just enough. Her pull remains steady, the earth still turns, and the tide, though at rest, has not forgotten its path. You breathe in, out. The water will come again, it always does. This is the lull in the rhythm, the moment between heartbeats, the space between inhale and exhale. Life does not always rush forward. Sometimes it ebbs. But the flow is never far behind. And tonight, as the stars gather higher in the sky and the first tiny ripples of returning tide tickle the shore, you understand something quiet and immense. Even the ocean knows how to rest, and in that rest there is peace. The tide has turned again. It's not dramatic. There's no splashy announcement, no sudden wall of water storming ashore, just a gentle hush in the silence, a subtle shift, the kind of change that only those paying very close attention can feel. And tonight, you're paying attention. The ocean begins its slow return, not in haste, but with certainty. The thin film of water that had receded over the sand stops, pauses, and then begins to slide forward, almost invisibly at first. Ripples gather at the edges of tide pools. Crabs halt mid-scuttle, sensing the deep call of their true home. The air thickens slightly, cooler now, scented with salt and movement. But You're just watching the tide return to the shore. You're watching it return around the world. Because the tide doesn't rise in one place. It's a global wave, or more precisely, a system of waves. It's always moving, always circling, always reaching new coasts. When it leaves your beach, it is arriving at another. Somewhere halfway across the earth, a new high tide is cresting while yours is just beginning. It's like breathing for the planet. While you exhale, someone else inhales, and together, life continues. To understand this movement, picture the ocean not as a still body, but as a great dynamic system. The tidal bulges, one facing the moon, one opposite it, don't stay fixed on the surface of the ocean. Instead, they sweep around the planet like slow, immense whirlpools guided by the Earth's rotation and bent by the continents. These whirlpools are called tidal waves, but don't confuse them with tsunamis. Those are seismic events. True tidal waves are massive, subtle rises in sea level, rotating around nodes called amphidromic points, the quiet centers we touched on earlier where the tide doesn't move vertically but instead spins in place. There are dozens of these around the world, in the Atlantic, the Pacific, the Indian Ocean. In each basin, the tidal wave flows in a great circular motion, counterclockwise in the northern hemisphere, clockwise in the southern, shaped by the Coriolis effect and the boundaries of the ocean basins. And these tidal waves don't move fast. While wind-driven surface waves can zip across the sea at speeds over 50 km/h, the tidal wave, or more technically, the progressive tidal wave, crawls. It moves at about 700 km in deep ocean, which may sound fast, but over the vastness of the ocean it's a slow and methodical pace. The water itself doesn't surge forward in great distances. The energy does. It's like how sound travels too, through air, or how a ripple moves through a slinky. And it's happening right now. Even as you lie still, even as your breath slows and the corners of your mind begin to soften, the ocean is moving. The tide is lapping at shores you've never seen. Black sand beaches in Iceland, palm-fringed coves in Fiji, the muddy banks of the Amazon Delta. The planet is alive with tide, and for many that movement is sacred. In parts of Polynesia, fishermen still chant to the tide. In the Torres Strait Islands, people tell stories of how the moon once descended into the sea, leaving her pull behind as a gift. In the Andaman Islands, some tribes believe the tide is a living being, a grandmother who walks the ocean each day, brushing the beaches with her wide skirt. You might think such stories are just myth, but consider this. In places where no clocks existed, people still knew what time the water would rise. They knew when to fish, when to plant, when to avoid the stormy waves that sometimes accompany the stronger tides. Their knowledge was passed down not in spreadsheets, but in stories. A fringe fact, the Inuit in the Canadian Arctic once used sea ice tides to navigate across frozen bays. As the tide rose and fell, the ice sheet would shift ever so slightly, cracking and groaning. The sound and movement, inaudible to outsiders, was their compass. Back in the temperate zones, things shift too. In Venice, a city built on water, the tides are more than a curiosity. They're part of daily life. During Acqua Alta, high tide events, often enhanced by spring tides or storm surges, the streets flood. Platforms are laid out, shopkeepers raise their wares, locals tie plastic bags over their shoes or simply walk barefoot, laughing as they slosh through centuries-old plazas. It's a rhythm, a challenge, a charm. But it's also a warning, because not all tides are created equal, and some are growing stronger. Climate change is not altering the moon or the sun, but it is. Raising the baseline. The sea level is creeping upward a few millimeters each year, and that changes the way tides behave. In places like Miami, Jakarta and Bangkok, high tides now flood streets even without rain. They call it sunny day flooding. What was once an unusual inconvenience has become a seasonal certainty. Tidal charts that served faithfully for decades now require revision, and more urgently, storm surges, essentially high tides supercharged by wind and atmospheric pressure, become more dangerous when stacked atop rising seas. A surge that once flooded a field now floods a home. Scientists still debate exactly how much sea level will rise in the next 50 years. Some say 0.5 meter. Others, if the polar ice collapses faster than expected, predict over 2 meters, but they agree on this: the tides will reach farther than they ever have in human memory. And yet, the tide remains itself, predictable, patient, unrushed. As it returns now to your imagined beach, the sand darkens again, pools fill, rocks vanish. The intertidal zone is swallowed whole, as though it had never existed at all. But you know better. You know that world will return, pulled from hiding twice each day, just as it always has been. It's a comfort, isn't it? That amidst rising seas, shifting winds, and a planet full of uncertainties, there is still this: the tide will come, and then it will go, and then it will come again. A steady whisper across the ages. Even now, when satellites track the tide from orbit, when supercomputers model it down to the minute, when cities plan billion-dollar defenses against it, the moon and the sea remain indifferent. Their dance continues, ancient and unbothered. You, resting now, are part of that dance. The bed beneath you feels more like a raft, rocking ever so slightly. The walls feel thinner, as if the ocean waits just beyond them, not 18ing, just there like an old friend. The sound of the tide returning is not a roar, but a lullaby. There are lessons in its motion. That power need not be loud, that change can be soft, that every retreat contains a return, that the world, even at its most complex, can still move in simple, eternal patterns. And so the tide rises. One ripple at a time. The water meets the sand again, and in that moment, just before the full return, just before the high tide swells once more, the world feels balanced, poised, peaceful. You, like the sea, are returning, high tide again. But this time, it feels different. It's not your first. You've followed the ocean's breath now, in and out, rise and fall, hush and flood, through the night and across the rhythms of the earth. Yet as the sea crests once more, something stirs beneath the surface. A deeper awareness, a curiosity that tugs like the moon herself. Where exactly does all this energy go? Because this motion isn't just beautiful, it's powerful. And that power, distributed across the globe twice a day, moves not only water, but the very crust of the earth. Yes, you heard that right. Tides don't just lift oceans, they lift continents. It's called earth tide or body tide. The solid ground beneath your bed actually rises and falls ever so slightly under the gravitational influence of the moon and the sun. Not by much, maybe 30 to 40 centimeters, but it happens. Every day, the crust flexes like a heartbeat in time with the sea. It's invisible to you now, but not to the scientists who track it with lasers and GPS. They watch entire cities shift upward and downward in a slow, silent wave, like mountains breathing. Even land, it seems, cannot ignore the call of the moon, and neither can the ocean's energy, because as the tides surge through the narrow mouths of bays, over shallow shelves and around island chains, they begin to generate internal waves, underwater tides invisible on the surface that ripple through layers of ocean density like long, LK ribbons. These internal tides can span hundreds of kilometers. They flow beneath the surface where warm and cold layers of water meet, and they carry heat, nutrients, and momentum across the ocean depths. They're vital to marine life and help mix the ocean's layers, preventing stagnation. And yet, we didn't even know about them until the 20th century. Before then, we assumed the deep ocean was still. Now we know it pulses, not wildly, but rhythmically, guided by forces we only recently learned how to see. Satellite altimetry, deep-sea sensors, and submarines have all confirmed it. Tides are not just surface events, they go deep. In fact, the deep ocean absorbs tidal energy like a sponge and slowly dissipates it as heat. This subtle warming, measured in fractions of a degree, contributes to thermohaline circulation, the grand conveyor belt of ocean currents that moves heat around the planet and shapes global climate. So yes, the tides are warm-blooded in a way, but the energy doesn't stop there. As tidal waves brush against continents and seafloors, they lose momentum. Not much, but enough to matter. And this tiny loss in energy, over millions of years, has an astonishing consequence. The moon is drifting away. Every year, the moon retreats from Earth by about 3.8 centimeters. It's not fleeing, just responding to physics. The gravitational interaction between Earth's rotating bulges and the moon's orbit creates torque, a drag that slowly transfers energy from Earth's rotation to the moon's orbital speed. The moon speeds up and drifts outward. At the same time, Earth's rotation is slowing down. That means the days are getting longer. Right now, we spin once every 24 hours, but 400 million years ago, Earth's day was only 21.8 hours long. That ancient rhythm can be traced in the fossil record, in corals that laid down daily rings like trees, in tidal sediments that mark ancient ebbs and flows. Our planet's spin and the moon's distance are both written in stone. It's humbling, isn't it? That the moon, steady, soft, glowing up there like a pearl, is also responsible for changing the very length of our days. There was a time, long before humans, when the Earth rotated faster. The days were shorter, the nights fleeting, the moon hung closer in the sky, larger and brighter, and the tides, they were stronger. The proximity of the moon pulled harder, the sea rushed farther in and roared louder as it rushed out. But slowly, over epochs, that force diminished. The moon drifted back. The Earth settled into a gentler rhythm. Civilizations arose and fell within this softened tidal tempo. And now, tonight, you sleep beneath a moon that once loomed larger, and will one day, millions of years from now, grow smaller still. Some scientists debate what happens if the moon drifts too far. Will tidal friction diminish to a whisper? Will Earth's rotation stabilize or become erratic? Could other celestial influences grow stronger? It's an open question, one that future minds, or perhaps no minds at all, may witness. But that drift, it leaves a trace. A whisper of time slowing, of oceans that once danced faster, now lulled into a longer waltz. Even more astonishing, some theorists suggest that without the moon's steady gravitational influence, Earth might not have been habitable at all. Its pull helps stabilize our axial tilt, preventing chaotic swings in climate. Without it, the seasons might have spiraled, too hot, too cold, too quick, for life to evolve into the complexity we know. So in a way, every tide you've ever seen, or every wave that touched your toes, every foam line left on the sand, and is part of the reason you're here. Breathing, dreaming, listening. Let's go stranger still. In 2013, scientists discovered that the gravitational pull of tides could cause seismic activity. They noticed that small earthquakes were more likely during certain tidal phases, ESP, especially at subduction zones, places where one tectonic plate slips beneath another. The added pressure of the ocean at high tide might help trigger faults already close to breaking. That's right, the moon might help cause earthquakes. Not all the time, not directly. But when a tectonic fault is primed, balanced on the edge of release, the additional mass of water during a high tide may be the final nudge. The sea, gentle, familiar, has the strength to shake the land itself. And still, we walk beaches without fear. Because most of the time the tide is content to rise and fall, to carry driftwood and seaweed and broken shells, to leave lines of foam and the tracks of shorebirds. It's calm, predictable, kind. But it's not weak. It's a patient giant, a sculptor of coastlines, a mover of planets, a record keeper of time. Tonight, as the water curls against stone once more, as the high tide returns to your imagined shore, you are not just witnessing motion. You are watching ancient physics at work, the transfer of energy across billions of tons of water, the subtle lengthening of the day, the soft push of a moon retreating into the night, and through it all, the rising, the falling, the drifting, you remain, cradled on this turning earth, floating in this quiet ocean of gravity, listening to the heartbeat of the planet. And it beats, still. The tide presses in, reaches its quiet peak, and holds there just for a moment. The world is full, complete, at rest, and so are you. There is a certain stillness at the peak of high tide. For a few sacred moments, the ocean is perfectly full, not rising, not falling, just present, suspended. You can almost feel the planet pausing in its breath, as if even Earth holds still to admire the balance. The moon, silver and distant, hovers directly overhead or behind, her work complete, for now. And in this quiet fullness, the true age, history of the tides is revealed. Not in the dramatic flood or the sweeping retreat, but in the influence they've carved into coastlines across time, because the ocean's edges are not random. They are sculpted by gravity and water, pulled into curves and cliffs and crescents, as if the sea were painting the borders of the world with every rise and fall. You can walk along almost any beach and see the signs: arches worn into rock, sea caves hollowed into cliffs, tide lines traced in bands of salt and shells. All of it, every grain of sand, every jagged edge, is a story written by tidal erosion. This slow chisel of water, moving in and out, wearing down even the hardest stone, is not fast, but it is relentless. Coastal erosion, driven by tides and waves, reshapes continents, not in days or even decades, but over millennia. The iconic white cliffs of Dover, created as ancient seas cut into chalk beds laid down when dinosaurs still ruled. The Norwegian fjords, carved first by ice, then widened and deepened by the gentle persistence of tides. And then there are the salt marshes. At first glance, these wetlands seem unremarkable, low-lying, muddy, insect-filled stretches between land and sea. But look closer. These are living coastlines, breathing in rhythm with the tide. Twice a day, the sea floods in, bringing nutrients, oxygen, and new life. Twice a day, it withdraws, leaving behind silvery channels and shimmering meadows of cordgrass. Salt marshes are tidal filters, purifiers that trap pollutants, buffer storms, and offer sanctuary to countless creatures. In North America alone, over 75% of commercial fish species spend part of their life cycles in tidal estuaries and marshlands. Without these zones, both marine life and human economies would suffer. Yet marshes are fragile. Rising seas threaten to drown them. Invasive species choke them, and when drained or filled for development, they vanish. King their quiet magic with them. Just beyond the marshes, you find mudflats and tidal sandbars, ever shifting under the tide's brush. These too are transient worlds, appearing and disappearing with the moon's pull. Birds flock to them, sandpipers, godwits, herons, feeding on worms and crustaceans that only the falling tide reveals. Somewhere in New Zealand, entire shellfish festivals are scheduled around the lowest tides, when massive beds of tuatua, a native clam, become accessible by hand. On the coast of Wales, ancient stone fish traps are still visible only at extreme low tide. They were built 1,000 years ago and still catch fish today. And then there are the tidal islands, islands that are only islands part of the time. At low tide, you can walk to them across narrow causeways or ridges of stone. At high tide, they vanish into the sea, marooned, cut off. Perhaps the most famous is Mont Saint-Michel in France, a medieval abbey perched on a rocky island that becomes completely surrounded by water at high tide. Pilgrims used to wade across the sands, racing the tide. Some did not make it. And even now the approach to Mont Saint-Michel carries a whisper of reverence, as if the sea still guards its secrets. There's something poetic about this, the idea of land temporarily claimed by the sea. The boundary between solid ground and flowing water is not fixed. It breathes, it negotiates, and tides are its language. Of course, human beings have never been content to simply observe this edge. We build at it, fight it, worship it. Entire cities have been planned around tides. London's Thames Barrier, for instance, is a series of movable gates designed to prevent tidal surges from flooding the capital. It can be closed in under 2 hours and has been used over 200 times since its construction in 1982. Venice has its Moes project, a set of inflatable barriers designed to rise from the sea floor when tides reach dangerous heights. It's a marvel of engineering, a reaction to a rhythm far older than steel. But not all efforts are so technical. In parts of Bangladesh, communities have learned to live with the tides rather than fight them. They build floating vegetable gardens, rafts of water hyacinth and bamboo that rise and fall with the tide. Their homes are elevated on stilts. Their lives move with the water, not against it. And this adaptive spirit is not new. For thousands of years, people along the Amazon River, itself subject to tidal influence even hundreds of kilometers inland, have planted crops on Varzea lands, floodplains that rise and fall with lunar phases. They time their harvests with the tides, not the calendar. A curious aside, the Amazon estuary experiences a pororoca, a tidal bore so strong that it pushes upriver with a crashing wall of water, sometimes over 4 meters high. It's become a destination for river surfers who travel from around the world to ride a wave that is born from the moon and shaped by the jungle. Surfers speak of it in hushed tones, not just because of the wave itself, but because of the sound. The pororoca roars for minutes before it arrives, a low gathering thunder in the trees, a voice of the ocean reaching deep into the heart of the continent. It is perhaps the most powerful reminder that tides are not coastal phenomena. Their reach is global, their touch subtle yet persistent. Even coral reefs, far from any beach, feel the tide. Certain deep-sea reefs, such as those around the Seychelles, feed only during incoming tides, when cold, nutrient-rich water is pulled upward from the depths. Their polyps extend, their mouths open, they dine on the invisible bounty the tide delivers. And in the deep-sea trenches, places of darkness and crushing pressure, the tides still flow. Submersibles have recorded slow, rhythmic currents thousands of meters below the surface. Even in the black silence of the Mariana Trench, water moves with the beat of the moon, which Lee adds us to this thought. The tide is everywhere. Not just in the foam at your feet or the tug of a boat's anchor, it's in the tilt of a cliff, the curve of a bay, the layering of sediment, the scent of a marsh, the echo of an ancient bore rushing inland. It's in your pulse, your breath, your sleep. Because the same gravity that moves the oceans moves the fluids in your body. The same rhythm that lifts water to the shore each night surrounds you as you drift beneath your blankets. You are a creature of tides. And as the ocean returns, as the high tide swells once again beneath a moonlit sky, it's not just the sea that rises, it's you. The tide begins to fall again, this time more gently. Like a sigh from a sea that's grown tired of holding itself up, it releases its grip on the shore, inch by inch. The high water, once brimming, begins to slide back with quiet ceremony. Pools of stillness form in footprints, and the slick rocks are revealed once more, gleaming under moonlight. But even as the water retreats, its impact lingers. Because the sea doesn't just touch the land, it transforms it. And one of the most fascinating transformations unfolds where rivers meet the ocean. Here, tides don't merely rise and fall, they clash and mingle, blending salt and fresh water in a delicate balance that shapes entire worlds. You've reached the realm of estuaries. Estuaries are watery crossroads, zones where rivers meet the sea, where salt meets sweet, and where tides become sculptors, gatekeepers, and alchemists. These are some of the most productive ecosystems on the planet, and they owe their existence entirely to the tides. As the sea rushes in, salt water travels upriver, pushing against the freshwater flow. When the tide falls, the river pushes back, shoving the salt toward the sea. The result is a brackish dance, a place neither fully fresh nor fully salty, where gradients shift with every moonrise, and life has adapted in remarkable ways. There are fish here that can switch their internal chemistry from freshwater to saltwater regulation in hours, plants that filter salt through pores in their leaves, crabs and mollusks that survive by burrowing deep, waiting for the tide to bring what they need. Oysters thrive in these zones, filtering gallons of water each day, clearing turbidity and providing food for others. But there's more than biology at play here. The sediments carried by the rivers meet the energy of the tides, and the two forces together shape the very floor of these estuaries. Sandbars shift, channels form and vanish. Entire deltas rise from the sea, built grain by grain as tides slow the river's flow and make it drop its silt. Without tides, many of the world's great deltas, like the Nile, the Ganges, the Mekong, would simply erode away. And it's not just natural deltas. Cities, too, owe their existence to tidal estuaries. The earliest civilizations formed where rivers met the sea, where the tides made transport easy and nutrients abundant. London on the Thames, New York on the Hudson, Shanghai on the Yangtze. Each one grew up in a place defined by the rhythm of the water. Some ancient cities even engineered the tide. In Mesopotamia, early engineers built gated canals and tidal inlets that allowed crops to be watered using the moon's rhythm instead of manpower. In the 1600s, in France and Britain, tidal mills harnessed the flow of the sea to grind grain. A great wooden wheel would be turned not by a river, but by the tide rushing in and out of a coastal basin. One of the oldest surviving examples stands in Woodbridge, England, where the tide still powers a mill built in the 12th century. The mill pond fills as the tide rises, and when the sea retreats, the water is released to turn the wheel. A perfect ancient machine driven by gravity and patience. And still today, that idea continues. Tidal barrages and underwater turbines, inspired by these early concepts, are now being deployed to generate clean, renewable energy. They don't just capture wind or sunlight, they capture reliability, because tides, unlike weather, are predictable centuries in advance. But as always, there are debates. Scientists and engineers argue over the long-term environmental impacts of these technologies. Will barrages trap sediments and starve downstream ecosystems? Will tidal turbines disturb migratory paths of marine life? Could altering the flow of estuaries affect the delicate balance of salinity and oxygen that countless species rely on? It's a difficult balance, one that asks us to listen carefully, not just to science, but to the rhythms of the place itself. And some places do listen. In the Bay of Mont-Saint-Michel, engineers redesigned a dam to restore the natural tidal flow to the estuary after decades of disruption. Where silt had choked off life, water now moves more freely, and bird populations have returned. The lesson was clear. Even when we've silenced the tide, we can sometimes learn how to let it sing again, and in that song we find stories. Because the people who live in estuarine lands often carry a deep, inherited understanding of tides. In the Sundarbans, the vast mangrove delta shared by India and Bangladesh, communities track the moon's position and the shifting tides to determine when to fish, when to travel, even when to plant. They believe the tides are governed by Bombibi, a forest goddess who protects them from the man-eating tigers that also roam the delta. Before venturing into the mangroves, fishermen leave offerings to her. They pray the tide will be kind, and it often is, because the tide, like any powerful force, is most dangerous when ignored, but when honored, understood, and respected, it nourishes. Back on your imagined shore, tide has receded further now. The brackish scent of estuary water drifts in on a breeze. Far off, the thin lights of a coastal village flicker on, reflected in the slowly draining channels. You imagine a child, maybe like you once were, leaning over the dock, watching a small fish dart between the roots of mangroves. In those tangled roots, protected by the tide, life begins. Juvenile sharks, tiny seahorses, shrimp no larger than a fingernail. They use these shadowy waters as a nursery, a safe space to grow before venturing into the wider sea. And all of them owe their survival not just to the plants, but to the tides that clean, flood, and feed these waters every day. Even coral reefs, so often thought of as oceanic fortresses, benefit from the nutrient pulses that estuaries release. The tide carries silt, minerals, even organic matter far into the sea, sustaining creatures you would never think to connect. This is the web, and at the center of it is not a predator or a ruler or a clock. It is motion, the motion of the tide. And perhaps what's most extraordinary is that it isn't chaotic. It's measured, mathematically describable. You can predict the height of the tide on any day 100 years from now. You can mark its path with lines on a chart. You can plot its effects with equations and graphs. And yet, no matter how precisely we map it, the tide never ceases to feel alive. It's no wonder that in ancient Greece, Thales, one of the first philosophers, believed everything came from water. It's no wonder that so many cultures treated the sea as a deity, a spirit, a living force. Because even now, when we understand the math, when we know the names of the forces involved, the moon's gravity, the centrifugal force, the Coriolis effect, something about the tide still feels like breath, not just in and out, but something more, like the planet itself thinking or dreaming. And so as the tide slides farther out, revealing channels and ridges and secrets once again, you find yourself not separate from this rhythm, but part of it, a single heartbeat in the pulse of the earth. And that is enough. The tide is now deep in its retreat. It has crept away almost entirely, like a secret slipping out the back door before dawn. What was submerged is now exposed, not only the usual tide pools and seaweed-draped rocks, but the very foundation of the coastal world. The seabed lies open like a page, and for those who know how to read it, every ripple, every hollow, every curve tells a story written in salt and time. You walk where fish swam hours ago, your feet pressed gently into sand still moist from the sea's embrace. The stars above seem more vivid now, reflected dimly in the water's memory, and beneath your steps lies one of the tide's oldest gifts, sediment. Yes, sand, silt, clay, the particles that form beaches, mudflats and deltas, all carried and sculpted by tides. These aren't just debris, they're the building blocks of continents, the slow-moving dust of mountains and glaciers ground fine over eons, poured into the ocean's edge. The tide, in retreat, doesn't leave emptiness, it deposits, and this deposition is critical, because it doesn't just shape the coast, it preserves time. In those layers of tidal sediment, scientists have discovered fossilized footprints pressed by beings long gone. In England's Norfolk coast, 850,000-year-old human footprints were found in tidal flats, some of the oldest ever discovered. Preserved for a brief moment in soft mud, then hardened by sand and silt before being sealed by the next tide, they are a ghostly reminder. Even the ephemeral can endure when the sea is your archivist. Elsewhere, in the Bay of Fundy, low tides reveal tree stumps, not driftwood but the fossilized remains of ancient forests, drowned thousands of years ago when sea levels rose. These preserved root systems stretch across the muddy flats like skeletal hands, whispering of lands that once stood where only gulls now cry. And in parts of Japan, shell middens, piles of discarded oyster and clam shells, form thick strata along estuarine edges. Archaeologists have studied these tidal garbage heaps to trace diet, climate, and settlement patterns going back 10,000 years. Tides don't just erase, they record. There's something reverent about this, isn't there? That the sea, in its coming and going, is both destroyer and conservator. That it takes and it gives in equal measure. That even as it erodes coastlines and shifts rivers, it also shelters stories in silt and time. And in those stories lie the traces of cultures long vanished, entire civilizations that thrived and vanished at the edge of the tide. One such culture, the Doggerlanders. Beneath the North Sea lies Doggerland, a sunken landmass that once connected Britain to mainland Europe. Around 10,000 years ago, it was home to Mesolithic peoples, hunter-gatherers who walked between what is now England and Denmark. They lived in forests, hunted in marshes, and fished in estuaries. And then, the sea came. Rising sea levels, likely accelerated by a massive underwater landslide called the Storegga Slide, sent waves crashing across the low-lying landscape. Over decades or perhaps even days, Doggerland vanished beneath the tide. Today, trawlers sometimes pull up mammoth bones, flint tools, and antler harpoons from its seafloor, a lost world hidden under the tide. And Doggerland is not alone. There are others, Campi Bay in Kenya, Pavlopetri in Greece, Dwarka in India. All ancient settlements, all swallowed by the sea, all still whispering their presence through ruins revealed at the lowest tides. It's a strange thought that entire cities could be waiting just beneath the surface for a particularly low tide to breathe them back into memory. And with sea levels rising, the process may soon reverse. Where the tide once revealed the past, it may soon erase the present. Many of our modern cities sit just meters above sea level. Miami, Jakarta, New Orleans, Dhaka. Some islands, like the Maldives or Kiribati, face complete inundation in our lifetime. The sea, patient and soft-spoken, does not hurry, but it does not forget its path. Scientists debate how fast the rise will happen. Is the Antarctic ice shelf melting at a linear pace, or does it hide the potential for sudden collapse? Will thermal expansion slow with cooler oceans, or does warming continue in the depths we cannot easily monitor? They agree on this. The tides of the future will come higher. And so, humans have begun to respond. In the Netherlands, instead of building higher dikes, engineers now develop room-for-the-river projects, letting water return to floodplains, embracing the natural tide instead of resisting it. Floating houses, amphibious architecture, and tidal urban planning are emerging across the world. The tide becomes a partner, not an enemy, and there is elegance in that. To design with the tide is to acknowledge its power and its permanence, to surrender, not in defeat, but in harmony. After all, the ocean was here long before us. It may well outlive us, but if we walk alongside it, step for step, ebb for ebb, perhaps we endure longer than we otherwise would. Of course, not all tidal mysteries lie in plain sight. Some are invisible, tucked away in patterns, numbers, and anomalies. Take, for example, the M2 tidal constituent, one of the most dominant components of the lunar tide. Scientists use this value, and others like it, K1, S2, O1, to model tides with extraordinary precision. These mathematical waves, layered together like notes in a song, form the harmonic analysis that lets us predict the tide centuries in advance. It's poetic in a way. The moon pulls on us, and we write symphonies of numbers to describe her pull. Yet even with this precision, mysteries remain. Why do some places have diurnal tides, one high, one low, while others have semi-diurnal, two of each, and still others have mixed patterns? Why do certain bays amplify tides to wild extremes while neighboring coves remain calm? The answer lies in resonance, the natural frequency of the ocean basin shaped by geography, depth, and boundary conditions. It's like pushing a child on a swing. If you push at just the right moment, the motion grows larger. The Bay of Fundy resonates perfectly with the lunar tide, and so the tide climbs to over 15 meters, the highest in the world. But here's the odd bit. There's no global average tide. Tides vary enormously from place to place. In some mid-ocean islands, the tide may only move a few centimeters. In Cook Inlet, Alaska, it can move over 12 meters. The tide is not a single wave washing over the earth. It is a symphony of local performances, each shaped by the shoreline's unique architecture. So when you stand at the water's edge and watch the sea go out, remember, this is not just the moon pulling, it's the earth replying. And that reply is filtered through valleys and bays, mountains and shelves, each response slightly different from the next. The tide you see is yours alone. And tonight, as it recedes again under starlight, your beach returns to silence. The waves flatten, the last traces of foam vanish into sand, and the sea, having spoken, waits once more to listen. You linger there, not quite land, not quite sea. Standing in that liminal space the tide has opened for you, a space between past and future, between stillness and motion, between what was drowned and what has yet to emerge. The tide is nearly gone now. Only scattered pools remain, quiet basins nestled in the dimples of the exposed shore, reflecting stars as if they've caught tiny pieces of the sky. You crouch beside one, and the world seems to hush a sans sourcil around you. Within that small circle of water, life pulses in miniature. Shrimp dart like sparks. Anemones wave gently with the invisible current. A snail leaves a glistening trail across a rock worn smooth by centuries of tidal motion. This is the intertidal zone, and though it may seem still, it is among the most extreme and lively habitats on Earth. Imagine living here, not just walking through it, but staying, rooted in a world that drowns and dries twice a day. Here, creatures endure more temperature variation in a single day than others might across entire seasons. They weather sun, wind, salt, exposure, and the crushing return of the sea, all in the name of survival, and survive they do. Mussels cling like armor to the rocks, sealing shut to conserve moisture. Barnacles lock themselves behind calcareous doors. Sea stars wedge into crevices, their slow, deliberate movements almost meditative. and limpets, those simple-looking mollusks, return to the exact same spot on the rock after every tide, grinding a tiny depression that fits their shell perfectly. Their little home scars are like keys to a door carved into stone. It's a world of rhythm, repetition, and resilience. But perhaps the most fascinating creature of this zone is the grunion, a silver fish that does something no other fish dares. During certain moonlit nights along the Pacific coast of North America, the grunion rides the high tide onto the beach, flopping and wriggling across the wet sand. The females dig shallow nests with their tails and lay eggs. The males curl their bodies around them to fertilize. Then, before the tide recedes, they slip back into the sea. The eggs stay behind, buried in sand. And here's the astonishing part. They don't hatch until the next high tide, 2 weeks later, when the moon's rhythm tells them it's time. The waves return, the sand loosens, and the hatchlings ash into the ocean to begin their lives, a birth timed to the breath of the planet. And yet we're only just beginning to understand how much this zone has to teach us. You might think evolution slows in such an ancient environment, but in fact natural selection here moves quickly. Just a few centimeters of elevation can mean the difference between constant submersion and hours of daily exposure. That means different adaptations flourish within the same square meter. Some scientists call the intertidal zone a natural laboratory, a place where life experiments with endurance. And it's not just biology. These narrow bands of land and sea have taught us about physics too. In the intertidal zone of Bay of Bengal, scientists studied the way wave energy dissipated as it passed over different sediment textures. What they found helped engineers design better wave breakers and seawalls, not by fighting nature but by learning from it. A scalloped shoreline disperses wave energy more efficiently than a straight one. Rougher sand dampens vibrations faster than smooth silt. The sea, as always, knows what it's doing, but we must remember this zone is fragile. Tide pools, once resilient, now face rising temperatures and acidification. As ocean pH drops, shells dissolve more easily, and creatures that once flourished begin to weaken. Even the humble barnacle, one of the most common intertidal dwellers, has shown decreased growth rates in waters made too acidic by increased carbon dioxide absorption. Scientists debate how quickly these effects will ripple through the food chain. Will predator-prey relationships collapse first, or will the zone adapt, creating new forms and functions we cannot yet predict? No one knows for certain, but time and tide will tell. And still, the zone endures, because the tide always returns. It's a fact you've heard now in so many ways, through erosion, resonance, fossils, fish, but tonight something about it feels deeper, more personal, perhaps because as the water reaches its lowest point and begins its almost imperceptible turn, you realize you've been walking in rhythm with it all along. And not just tonight, your own body carries echoes of the intertidal dance. Human cells, ancient and modern, contain sodium, potassium, calcium, salts in ratios that match the oceans of early Earth. Some scientists suggest our very biochemistry is a fossil record of when life first arose from sea to shore. Our blood, in a sense, is the ocean remembering itself. Even our circadian rhythms, the cycles that govern when we sleep and wake, are shadows of tidal rhythms. In coastal animals, these rhythms are not just tied to the sun, but also to the moon and tides. Some crabs have separate internal clocks, one for the solar day and another for the tidal cycle. They anticipate the rising water hours in advance. And what of humans? While we've moved inland, built walls and dimmed the stars with electric light, our sleep patterns still fluctuate around full moons and shifting tides. Studies have shown that even landlocked people often sleep less on nights with high lunar brightness. Why? Perhaps the pull never left us. Perhaps it never could. It makes sense, then, that people have long seen the tide as more than science. In Celtic myth, the tide was controlled by Manannán mac Lir, a sea god who rode over the waves in a chariot drawn by horses. In Maori stories, the tide's ebb and flow is caused by Hina Moana, the ocean goddess, weeping for her lost love. In parts of Africa, elders teach that the tide is a story being told by the moon to the earth, one verse in, one verse out. And in your own life, haven't you felt this rhythm even without noticing? You build, you rest, you rise, you retreat, just like the tide. Tonight, that rhythm feels closer than ever. You're not watching the tide now, you're part of it. The sand beneath your feet is cooling, drying. The last rivulets trickle toward the horizon, and already you feel the slightest pull forward. The beginning of the next tide. And in that beginning, there's comfort. Because no matter how far the water recedes, no matter what it reveals or hides, no matter how ancient or modern the coast becomes, it will return, not with force or fury, but with grace, with familiarity, with the soft certainty of a promise kept. And that's what tides are, really. A promise that everything cycles, that no state, not high, not low, lasts forever. That loss is not always the end. That retreat makes way for return. As you rise and stretch under the stars, brushing sand from your palms, you feel it not only in your muscles but in your thoughts, the quiet understanding that change doesn't have to be sudden to be powerful. That persistence, like the tide, can shape the world, and shape you too. Somewhere far out at sea, the moon tugs gently. The earth responds, the water stirs, the tide turns, and you are ready. The tide is turning, not in a dramatic swell or crashing wave, no, its motion begins as the gentlest nudge. The pull is almost imperceptible, like a whisper deep beneath the sand. A delicate reversal. The sea, having reached the farthest edge of its exhale, begins to breathe in once more. And just as before, that subtle motion brings transformation. Where minutes ago the beach lay bare, the water now creeps in again, filling cracks, caressing rocks, lifting the strands of kelp that had slumped in the sand like tired limbs. Pools left behind begin to brim anew, stirred by the returning tide. The earth, pulled by the moon, curves gently toward fullness. This is the flood tide, the rise. And though we've watched it countless times, there's still magic in its method. Because as the sea advances, it doesn't simply refill what it left behind. It builds anew, layer by layer, pulling stories forward from the deep. Bits of shell, driftwood, tangled threads of seagrass, all carried in by this deliberate puer. Ossession. You see the tiniest crab scuttle across the sand, as if answering a call older than sound. A heron lifts its wings and glides to a higher perch, sensing what's to come. And what's coming is not just water, it's connection. Because every time the tide returns, it brings faraway waters to your feet. Currents stirred off the coast of Africa may one day touch the shores of Brazil. Waters from the Arctic may drift into the Pacific. The tide is not an isolated rhythm, it is global coordination, a planet-sized pulse in which every bay, beach and inlet participates. This connectivity makes the ocean a single body, and tides are its breath. Scientists have long studied how this breath travels, not just across the surface, but through the deep ocean conveyor belt, that vast underwater circulation system powered in part by differences in temperature and salinity, but subtly modulated by tides. When tides interact with underwater mountain ranges and continental shelves, they create turbulence. That turbulence mixes waters from different depths, distributing heat and nutrients. Without this mixing, the ocean would stratify. Warm water on top, cold and lifeless below. Life would vanish in stages. Tides, then, are life's quiet custodians. And they don't just connect ocean layers, they connect species too. You may not realize it, but many marine animals time their reproduction to the tide. Corals, for example, release their eggs and sperm into the water column in a synchronized burst, a luminous snowfall of life, timed to the lunar cycle and the turning of the tide. This phenomenon is called mass spawning, and it's one of the most remarkable spectacles in nature. For a few nights each year, under the glow of a full moon, entire reefs seem to bloom in the water. Tiny packets of future life drift with the incoming tide, carried far from their origins to settle on new reefs, new coasts, perhaps even continents away. And it's not just corals. Grunion, as you've met, do it. Horseshoe crabs too. Every spring along the eastern seaboard of North America, these ancient armor-plated creatures, virtually unchanged for 450 million years, emerge en masse at high tide. The females dig into the sand to lay eggs while the males jostle for position. Birds, especially red knots, time their migrations to this exact moment, feeding on the rich clusters of eggs. Tide as midwife, tide as calendar, tide as feast. And then, beyond biology, there's us. Humans. We too have learned to move with the tide, though in more abstract ways. We've timed battles to the turning of the sea. In World War II, the Allied forces chose the exact hour of the D-Day landings based on the combination of low tide and moonlight. Too early, and their ships would hit hidden obstacles. Too late, and enemy visibility would grow. The tide, silent, ancient, helped shape the course of history. Even in peace, we read its language. Sailors once learned to chart their journeys not just by stars, but by tidal patterns. Fishermen, especially in traditional cultures, knew how to listen to the water, observing the slight delays in the return flow, the way certain smells changed before a rising tide. In Japan, the Ainu people could predict the tide by watching the movements of dragonflies and birds. And then there are the tide watchers. Every coastal town has them. The old man with his chair near the jetty, the child counting waves, the surfer pacing for the right moment. People whose lives are tuned to the moon in ways they don't even articulate. They know when the flood tide will breach the sandbar. They sense when the current shifts by the feel of the breeze. They might not call it astronomy or hydrodynamics or resonance, but it is all of that and more. Because the tide is not just science, it is intuition. A sixth sense, a knowing, and yet despair. Like this deep familiarity, there are places where tides turn strange, places where the water defies our expectations. Take the Saltstraumen in Norway, one of the strongest tidal currents on Earth. Here, as the tide rises, seawater rushes through a narrow strait at speeds up to 20 knots, creating massive whirlpools. Boats must time their crossings with care. Even experienced captains pause at its edge, watching the sea's surface ripple with warning, or the tidal whirlpools of Japan's Naruto Strait, where the tide flows through a funnel of sea between Awaji Island and Shikoku, forming perfect spinning vortexes. From above, they look like galaxies turning in the ocean. Then there's the Miarim River bore in Brazil, where the sea surges upriver with such force that it forms a standing wave, surging inland for miles. Locals say it roars like 1,000 drums. Surfers wait for it, a ride not on ocean swell, but on the raw breath of the moon meeting land. These tidal anomalies remind us that, while the equations hold, the experience of tide is still full of wonder. It is not fully tamed. It does not belong to us. And that is perhaps the most comforting truth of all. Because in a world increasingly designed, digitized, and engineered, there is still something so vast, so graceful, so quietly untouchable that it resists control. It simply is. And you, standing at the shoreline with the water beginning to rise around your ankles, feel not overwhelmed, but aligned. You are not separate from this rhythm. You are embedded in it. The stars overhead shift slightly. The moon's angle adjusts. The pull deepens. And the tide, so slow a moment ago, now laps around your knees. The sea has begun to return in full. And you're ready to walk with it. Not because it demands anything of you, but because its movement has become part of your breath, your heartbeat, your thoughts. You have traced its cycles across history through biology, over mathematics and myth. You have walked its margins in low tide and felt its weight in high. You have seen what it reveals and what it takes and what it returns, and now you feel it carry you forward, toward one final rise, toward the end of the night, toward the peace of knowing. The tide always turns again. The tide is rising fast now. Gone are the shallow trickles and hesitant swirls. This is the ocean reclaiming itself, not with a crash, but with a steady, elegant force. The sand that once stretched wide and open is vanishing, swallowed minute by minute under an ever-deepening veil of water. Rocks disappear, footprints vanish, pools blend into one vast surface again, glassy and gliding beneath the soft, silver light of the moon. You pause for a moment, standing at the edge where the sea and night meet. This is high tide's approach, the crest of the ocean's breath, the peak of the planetary pull. It feels like a homecoming. The water laps at your ankles, gentle but insistent, as if inviting you to remember something long forgotten. And in this moment, it's hard not to feel small, but not in a frightening way, not as if you're insignificant. Rather, it's the smallness of scale, the awe that comes from seeing your place in something so much larger, so much older, so much more constant than yourself. You're not out of place here. You're exactly where you belong. Above you, the moon hangs low and full, radiant and solemn. It has watched this ritual for billions of years. It has shaped the water's rise and fall since long before your kind ever walked along these shores. It is your clock, your tide setter, your silent companion. You wonder how many others across time have stood as you do now, barefoot, quiet, heart slowed, and watched the water return. Ancient fishermen on distant coasts, sailors scanning the horizon, children playing beside tide pools, lovers watching the moon's reflection lengthen on the wet sand, all of them joined to you now by this simple act of bearing witness to the sea's slow return. In that thought, there's a thread of peace, because the tide doesn't just move water, it moves memory. Tides have been etched into language and metaphor for millennia. Shakespeare called life's fortune a tide in the affairs of men. Emily Dickinson wrote of the tide that tried to climb the stairs. Even now we speak of turning the tide in politics, in illness, in emotion, as if deep down we recognize that what rises must fall and what falls must rise again. These are more than phrases, they are truths, and science too finds poetry in this motion. Geophysicists studying tidal flexing on other worlds believe moons like Europa and Enceladus, orbiting distant gas giants, may host liquid oceans beneath icy crusts, kept warm by tidal forces. The same pull that moves Earth's waters may warm alien seas, may stir life beneath frozen plains. Our tide may not be unique, which leads to a question many scientists still argue over. Is tidal motion necessary for life? Some theorize that Earth's early intertidal zones with their repeated wet-dry cycles may have been ideal for forming complex organic molecules, life's first spark. In drying pools, concentration rises, compounds interact, energy cycles. Could it be that without the tide, chemistry never becomes biology? No one can say for sure, but the idea is compelling, that the tide not only nurtures life, but might birth it. And still, it keeps time. You can trace its pattern years into the future or centuries into the past. Astronomers in ancient China recorded tidal shifts as early as 600 BCE. The Greeks knew of tidal timing in connection to the moon, and in the 11th century, Muslim scholar al-Biruni described the varying tidal ranges across the Arabian Sea. And yet, some of the most sophisticated tidal records come not from scientists, but from indigenous peoples. The Yolngu of northern Australia distinguish between 6 different tides, not just high and low, but subtle variations based on wind, season, and moon. Polynesian navigators feel the ocean's rhythm in their canoes. The Bajo of Southeast Asia, ocean nomads for generations, speak of the tide as if it breathes. They do not need a calendar. They need only the moon. So many names, so many stories, all pointing to the same pulse. And here you are, standing in it. The tide is nearly full now. Only the tallest rocks still peak above the surface like islands drifting in a slowly deepening world. The water presses against the shore, not as a threat, but as a blanket, smooth, encompassing, patient. It is, after all, only water. And yet it carries everything. Life, time, energy, myths, mathematics, memory. It moves without rage and returns without permission, and always it knows the way home. You feel it now around your legs, that soft resistance, that gentle insistence. It welcomes you into something vast and yet somehow personal. You close your eyes. Let the sound of the water replace your thoughts. Let the hush of waves fill the spaces between your breaths. Let your body sway slightly with the motion, as if pulled not by force, but by invitation. The tide is high. The moon is watching. And you, small, infinite, alive, are ready to drift. And now, dear traveller of tides, it's time to rest. Let your thoughts ebb like the sea at twilight, slow and soft, until only ripples remain. You've walked the shifting shorelines of time, traced the moon's invisible fingers as they stirred entire oceans, and felt the rhythm of a planet that breathes in waves. The journey may have begun with a question, how do tides work? But somewhere along the way, it became something gentler, deeper, quieter. Like a lullaby told in salt water. You are not separate from these motions, you carry the ocean's memory within you, in your blood, your heartbeat, your breath. You are tide-born, tide-born. Every rise and fall around you is echoed within. The earth turns, the moon drifts past, and the water answers, always answers. So, close your eyes now. Imagine yourself floating just offshore, the water warm and still, the stars spread out above like scattered bioluminescence across the night. There is no need to move. The tide will carry you. The moon will keep watch. The sea, ancient and patient, knows exactly where you are. Let it hold you. Let it hush you. Let it rock you into dreams. And if, in sleep, you feel the slightest pull, a rhythm rising beneath your chest, know that it's only the tide returning again, like it always does. Good night, dreamer. May your thoughts be as calm as a moonlit sea and your sleep as deep as the ocean's heart.